In this video, we will look at another peer-to-peer application, Kazaa, an application that has learnt its lessons from Napster and Gnutella. But first, a few questions. So before Kazaa came into being, there was Napster and Gnutella, and people have dug in enough to understand what works and what doesn't work with respect to peer-to-peer systems. So Kazaa is a cross between Napster and Gnutella where it leverages the advantages of both. So if you see in Napster, the search is very efficient because you're just contacting a centralized server. But the problem with Napster is that central server could be a single point of failure. In contrast, Gnutella is fully distributed, but search is rather inefficient because you have to rely on flooding. But it's quite robust because even if some node fails, there are other nodes within the overlay network that can help you. So as Gnutella scaled, people had found other issues with Gnutella, and one of the problems people have seen is that Gnutella actually treats all peers as equal. All contribute equally to the process. So what was happening is that peers that have limited resources that are, for example, using dial-up modems that have very low bandwidths, these are turning out to be the bottlenecks in the particular system, thereby degrading the overall performance. So Kazaa tried to overcome this problem basically by leveraging the heterogeneity of the different peers. In other words, there are some peers that have better resources than other peers. By better resources, I mean these peers are almost always on, that is, they are a lot more available. They have high bandwidths and processing powers. So what Kazaa did was it started assigning more responsibility to these peers with better resources. So these nodes with better resources are called super nodes or peers. And it is going to impose a hierarchy in the overlay network by making use of these super nodes in a special way. We'll see what it is. So here is Kazaa architecture. As I said, there are these special nodes, super nodes that are given as by these blue circles, and then there are the regular peers and nodes that are given by these black circles. Now what a super node does is it acts as a central server, much like in Napster, to some clients. So when I said it imposes a hierarchy, this is the hierarchy. This is tier 1 of the hierarchy and this is the tier 2 of the hierarchy. So this supernode is acting as a server, central server to the subset of clients. Search is very efficient from the perspective of the clients because they are just going to query their supernode for an answer. They are not going to flood. So who becomes a supernode? Any node can become a supernode at some point based on its capabilities, typically the bandwidth capabilities, and how long has it been on. So if you leave your laptop or computer on all the time, there's a good chance you can become a supernode. With, of course, you should also have good bandwidth capabilities. Typically, a supernode serves about 100 to 150 nodes or peers. So where does Gnutella come into play? These supernodes are going to form a distributed network much like in Gnutella. So this is robust because even if one supernode fails, there are other supernodes that can take over its responsibility. So they're going to share the load and provide this robustness. And again, typically one single supernode has about 30 to 50 connections with other supernodes. So unless we actually go through this node join, publish, search, fetch, things won't be clear. So before I get into it, since I've given you the basic idea, before we proceed further, spend some time, figure out how node join can happen, publish can happen, search can happen, and fetch can happen in Kazaa. So node join is very similar to what happens in Gnutella. So to begin with, some supernodes are hard-coded in the downloaded software, and peers are going to contact these hard-coded supernode one by one till they find an operational supernode. And from this supernode, this peer is going to get a more up-to-date list, up to 200 entries of current active supernodes, and then it is going to contact the supernodes on this list and it will connect to whoever replies to it. So typically these supernodes are always on, but in case anything happened to the supernode that it is went down, it is going to choose another supernode from this list and connect to the overlay. And publish is very similar to Napster. So a node will inform the supernode of the list of files it wishes to share, and the supernode is going to store this information. So what information should be uploaded for each file? Well, the file name, the file size, hash. This will help determine identical copies. We'll see why this is needed shortly. And also some file descriptors, so that when people search using keyword search, the supernode can quickly match whether it matches the file or not based on the keyword. So this is how search is done in Kazaa. A node is first going to query the supernode it is connected to. And this supernode, if you remember, is connected to many other nodes. So it knows what all files these other nodes have that it is serving. And if it found X matches, you're done with search. You can reply back with these X matches. Now, why do you think it is asking for X matches where X is a number greater than 1? Well, for efficiency purposes, where if the file is available at, let's say, 5 nodes, it can start downloading different chunks of the file from these different nodes, thereby improving its download time. It has another advantage. If one of these nodes goes down, it can always resume the file transfer from the remaining nodes. So going back to search, as I mentioned, the node first contacts the supernode. If X matches are found, the search is done. Otherwise, if the supernode did not find X matches, it's going to flood within the overlay formed among the supernodes. So this is very similar to Gnutella. So it does this limited scope flooding. In other words, it will set the TTL value to some, let's say 3. If it will see if it can get X replies. If it is not getting X replies, it will increase this value, let's say to 4, and try to get X replies. It does this flooding till X matches are found. And once X matches are found, it is going to respond to the node with these matches. What do you think these matches will contain? Basically, the matches will return the metadata and the IP address of the peer which has the file. Remember, as part of the publish, each supernode maintains a list of file and which peer it is serving has that particular file. So when a given supernode gets a query, it will refer to this list and pass this match information back to the query initiator. Fetch is rather straightforward. So a given peer has X matches. And as I mentioned, when it has X matches, it can do something called a parallel download. In other words, what it can do is it can say, I want 0 to 1000 bytes from node 1 and 1001 to 2000 bytes from node 2, so on. So this is possible via the HTTP byte range header. So this will permit parallel downloading of different chunks of the file from different nodes. Now tell me, I said it had X matches. How does it know that all these nodes have identical files? Well, this identical copies can be determined by the file hash, which is included as part of the metadata. As I mentioned already, the HTTP byte range is used to download different portions of the file from different nodes. So whatever I have described is in action here. So this is the Kazaa network. So we have one client here which has this IP address. Let's say it has the song Hotel California, which it is ready to share with others. So all it will do to publish is to contact the supernode and say, I have this file that I want to share, and thereby this supernode is just going to insert this record which says Hotel California. Of course, there is some metadata, etc. is at this particular IP address. This node wants this particular song, Stairway to Heaven. It is going to send a query to the supernode it is connected to. And what this supernode will do, like in Gnutella, it is going to flood. So it is going to pass this query to other supernodes, which in turn can pass it to other. And let's say this supernode as well as this supernode have the song, and this supernode has the song at this particular peer, and this supernode knows that the song is at that particular peer. So what they are going to do is they're going to reply. So this reply came like this and this reply came like this, and this supernode will pass this information back to its peer. So after this point, this peer can do parallel downloads from here as well as here. So this is more or less what is there with Kazaa. Given your understanding of Kazaa, what do you think are the advantages of Kazaa and what do you think are the disadvantages of Kazaa? Well, it improves scalability and search efficiency, but by leveraging the node heterogeneity. So it definitely does better than Gnutella. But even here, the problem is that there are no guarantees on search time. And again, there is no mechanism to tackle freeloading, where freeloading is the case where nodes download but not upload. Before I conclude, I will briefly touch upon Skype. It comes as a surprise to many that Skype's architecture is actually based on Kazaa. Skype is a peer-to-peer application whose underlying architecture is very similar to Kazaa. I think many people know what Skype is. It's an IP telephony application. Basically, it provides the ability to make voice, video, chat calls from computers, mobiles to other devices, including telephones. And it makes use of the internet for this. So it turns out to be a lot cheaper to use Skype to make calls. So Skype's developers were the same as Kazaa. In fact, that is why the architecture is similar to Kazaa. Apart from whatever architecture we have seen of Kazaa, Skype adds a few additional servers. Login server is needed for authentication. Apart from that, since Skype interfaces with the PSTN, which is the public switch telephone network, the telephones to, you can talk from your laptop to someone who has a telephone. So for that, it needs the Skype out and Skype in servers as well. One thing which people particularly appreciate about Skype is that it provides excellent NAT and firewall traverses. Typically, when you are behind a NAT box or a firewall, it is very difficult for others to communicate with you. But Skype has mechanisms in place, which I'm not going to cover here, to enable this NAT and firewall traversal. Very briefly, here is how Skype works. So this is the Skype architecture, the peer-to-peer overlay that we have already seen with respect to Kazaa. And here is a login server that Skype adds. Suppose this peer A wants to connect to the Skype overlay. It first has to authenticate itself. It does it via the login server. Skype messages are heavily encrypted, so this also takes care of some security mechanisms. Let's say after this, A wants to find a buddy B, then it is going to initiate a query that is asked at supernode where is B, and the query flooding, everything happens much like in Kazaa. So this supernode, after finding out where the buddy B is in this overlay, will get back to A saying B is at this particular IP address. After this, if A wants, it can connect to B directly and have a voice conversation. So to summarize, Kazaa is a cross between Napster and Gnutella, where it tries to take advantages of both architectures. Basically, it leverages the heterogeneity of nodes and imposes a hierarchy in this overlay network. So it introduces this concept of supernodes. These supernodes form a distributed network like in Gnutella, but they act as a central to a subset of clients or peers as in Napster. So this improves scalability as well as searchability. Kazaa is kind of outdated, but Skype, which is very popular even to this day, is based on a similar architecture.